The day 27th is also an important, and you will see why it is. So let us begin with an understanding of this National Science Day, because it was since 1987 that this idea of celebrating, of commemorating Raman's work, which is the only Nobel Prize in physics that we have got for our country. Although there have been other contributions by Indian physicists which have been almost as good, and some of them have also been nominated for the Nobel Prize, and whether or not one actually gets it is a matter of several factors. You make it, you don't make it, but there are many other works, and in particular I would like to mention the work of Meghnad Saha, Satyendranath Bose, many others actually, George Sudarshan, many. So Raman was awarded the Nobel Prize in Physics for his work on scattering of light and for the discovery of the effect. Don't forget, and there are two reasons why he got a Nobel Prize. Not just the Raman effect, but for his overall contributions to scattering of light. And all of these are important contributions. Before Raman, Meghnad Saha and Satyendranath Bose did extremely good work. And Meghnad Saha was nominated 6 times for the Nobel Prize in 1930, 37, 39, 40, 51, and 55. I didn't get it. 1930 is also the year when Raman got the Nobel Prize. Raman was nominated for the Nobel Prize also in 1929, but he got it in 1930. He was nominated twice. And Bose, of course, is someone that all of you would have known, because there are elementary particles are of two kinds, either integer spin particles or half integer spin particles, and the integer spin particles are named after Satyendranath Bose. They are called bosons, so it's a great contribution. And the works of Meghnad Saha and Bose both have to do with the important recognition of this thing is not showing nicely on the slide. This font is obviously h nu, which I'm sure all of you would have read correctly, E equal to h nu, which comes from Max Planck's work in 1900. However, that of photon is the corpuscle of energy, which was a proposal by Max Planck, and it worked all right to explain the black body radiation, as all of you would have known. That by itself does not give the full character of a photon. It needed further contributions, and a significant contribution came from Einstein in 1905 when he explained the photoelectric effect using the corpuscular nature of light. Even that was not enough. Subsequently, the statistical distribution in an electromagnetic field had to be established, and that work was done by Satyendranath Bose along with Einstein. And that is the reason I prefer to call H not just as Planck's constant, as everybody does, but I like to call it as Planck-Einstein-Bose constant, or PEB constant, because E equal to h nu does not acquire its full meaning without the understanding we get from Einstein and Bose. So my recommendation to all of you is to refer to H as the PEB constant, as the Planck-Einstein-Bose constant. Meghnad Saha also used this idea of a quantum of light in his study of stellar spectra, and there is a very famous equation in astrophysics which is named after Saha. It's called as the Saha equation. But today we are reflecting on Raman's work. And Raman nominated 12 times for the Nobel Prize. And it's amazing that his work was done in 1928, February 27 and 28, as I mentioned, 28 actually. But then he got a Nobel Prize very quickly, which is really amazing. Like many others, take a lot of time. Means look at this spectrum. This is such a simple thing that he used to carry out his measurements, and he got Nobel Prize winning work was done on such a simple instrument. And somebody like Raman, it's not easy to visit his life and works in a short talk like this, and I'm too small to even make an attempt. And I'm sure there are many learned people here, and sometimes I'm never surprised to come across students who know even more than anybody else in the hall. But what happens is, Raman's work is so rich, it is impossible to review it. Which is why I decided that I will talk about some of the controversies which surrounded Raman. Some interesting controversies. One of which is whether he should have shared this prize with some others, and did he do injustice to some of his collaborators or to others who also. And great people always attract controversies. There is nobody who doesn't, whether it is Gandhi or even Purushottam Ram. So controversy around Raman. So this is one of the controversies. So let's talk. And should they have had a share as joint winners of the Nobel Prize? That's the question which a lot of people ask. So we are talking about 1928, and 5 years prior to that, in April 23, Ramanathan did some experiments, who was a student of Raman, and he observed scattering of light by water. And there were some characteristic features in that experiment which Ramanathan observed. And have some sort of an impact on subsequent work which followed. But nothing was understood. It's only some interesting observations were made. It doesn't mean that you knew what was really going on in the experiment. It was attributed to some fluorescence due to some impurities. So, whenever you see anything unusual, you need to take that seriously. Pay attention, find out what's going on. Is it just impurity, or is there some phenomenology which is taking place? So that's a matter of science. And in the experiments of Ramanathan, only some fluorescence, peak fluorescence was suggested as the cause for the observations. And Raman himself wrote that it was Raman himself who was not satisfied with the explanation. So Ramanathan would not have any claims to be the one who actually figured out what was going on. And in fact, he points out that it was Raman who was keenly interested in the phenomenon and wanted to know what was really going on. And Raman thought that it had something to do with molecular scattering, and there was some other physics which was going on which had to be investigated. So Raman continued his research. This was 23. And now we come closer to when the discovery actually took place, which was in 1928. And in January, another student of Raman, Venkateswaran, he observed that the scattered light from pure glycerine was greenish in color instead of. So again, there was some interest in what was going on, and they tried to figure out how exactly, what was the cause of this departure from color that was expected. But nobody actually figured out. Raman had some thoughts, but nothing was clear by then. And then a little later, K.S. Krishnan, he also made some, carried out some experiments. He also observed the phenomenon. And Krishnan was actually doing theoretical physics at that time. And Raman told him that it was not healthy for a man of science to stay out of touch with actual experiments for any significant length of time. And I feel very embarrassed to read this because Suresh introduced me as a theoretical atomic physicist. So I'm sorry for that. Although my own PhD work was in experimental physics, but that was quite some time back. Nonetheless, Krishnan also reported the same findings which Raman had observed. Raman himself carried out those experiments and verified this. This is how research takes place in all the laboratories, supervisors, students go back, report. Supervisors verify, carry out their own investigations, and then arrive at some conclusions. 1928. And by this time, Raman was gaining some confidence. He realized that this was happening due to some particular phenomenology in the molecules. So he sent a note to nature. And nature is means everybody over here knows, but some of the young students may not be knowing. This is a very reputed journal. Even today, it continues to be one of the most important journals in science. So Raman sent a note on 16th February that there was modified radiation which he was observing in his scattering experiments. And even at the time, just a few days before the actual discovery of Raman effect took place, nobody, including Raman, had a clear understanding of what really was happening. And then on 27th February, that is the date whose anniversary is today. And that's the reason I mentioned that it is an important day, although the actual day of the discovery is 28th of February. So 27th February, Raman set up an experiment in which he decided that he will do this experiment very carefully and try to figure out exactly what was happening. However, the experiment could not be completed on 27th because, by the time they set up everything, it was the end of the day, so they were ready. And then they came back the next day, 28th of February, when the experiment was done. And the next morning, which was February 28th, Raman himself carried out the experiment. And he found the scan. And he provided an explanation for that. The first observation of what we now call as the Raman effect. This was on 28th of February. And then 29th of February, it was a leap year, 1928. So on 29th of February, Raman sent a note to Nature. He made an announcement and then he sent a note to Nature on March 8th. And he provided the complete explanation for this. The second part. And quantum mechanics in 1928 was a very young, and a very revolutionary. Act. It was not even a decade old at this time. It was Schrodinger's work and Heisenberg's work and all Dirac's work. They were in the mid 20s, 1924, 25, 26, and so on. Dirac, 1928. So it was based on quantum mechanics. And the committee which selects the winner of the Nobel Prize Award, they go through all the nominations. All the collaborators, Ramanathan, Venkateshwaran, Krishnan, all of them were known to every member of the committee. It's not that they were not aware of this thing. And with this full knowledge, the award was given to Raman alone. Why he was the only one to get it is not Raman's responsibility. It's the responsibility of the committee. And this committee scrutinized all the evidence, and they do it very carefully, mind you. There are many controversies. They have to justify their decisions. It's a very competent committee. They have to justify their decisions. The writer was even nominated. Previous slide on which there were names of various persons, and I'll show you on a slide on which who else was nominated. So here are the nominees for the Nobel Prize of 1930, which include Raman and several others, including Meghnad Saha. And if Krishnan or Venkateshwaran or Ramanathan or anybody, they don't appear anywhere. They were not even nominated. And they certainly carried out experiments, reported them to, and they played an important role. There is all there is to it. There is who also did similar experiments. However, this study was made, what was really going on, and he will settle. Landsberg, at this time, was a few days later, February. But most importantly, is the letters by Raman and Krishna to Asia, which published in March. Landsberg and Mandelstam's work was published in July, much later. So it is always the first. Okay, means if Hillary and things are the first ones to get there, they remain the first ones. Anybody else can get there any number of times. Today you can carry on. Effectual anything. And most importantly, so they actually cited Raman's work, and in fact they went on to say that okay, what they see is science Raman has observed, but we are not exactly sure if it is the same. So all these factors were considered fully by the committee, and the award was made very deservingly to C.V. Raman. And some other aspects of Raman's life. So I think this pretty much resolves the controversy surrounding Raman. So interesting episodes in his life I picked for today's discussion. Sporadic, nothing continuous. Raman visited Copenhagen, and Niels Bohr, who I'm sure everybody knows, Niels Bohr wrote to him in Note the date, 29. So this was after the Raman effect was published in Nature. And Bohr wrote to him saying that we often think about your visit a few years ago, and I take this opportunity to express my most cordial congratulations to you for your great discovery of the new radiation phenomenon. Now, Raman, he replied, and what would he reply? He said that, okay, get me a Nobel Prize. So look at his reply. Okay, Raman wrote back to Bohr. He said that the great kindness you have shown me in the past encourages me to make a request of a personal character. As you know, my work on the new radiation effect has been received with enthusiasm in scientific circles, and I feel sure that if you give your influential support, the Nobel Committee for Physics will recommend that the award for 1930 may go to India for the first time.
You asked for himself.
Yeah.
For India.
Yeah, he asked for India. He asked for India. And the implication was obvious, but he had the confidence, he had the courage, he had the conviction that his work was important. And when you do good work, claim credit for it. Because don't assume that it will automatically come. And Raman had the courage to do that. So it's a great lesson for youngsters. Subsequently, Raman, however, when he wrote this letter, he did not know that Bohr had already nominated him not only for the 1930 Nobel Prize, but even for the 1929 Nobel Prize. So Bohr nominated him twice. And in 1929, also Bohr had nominated. And here is another interesting thing about Raman's Nobel Prize. Planck's work was in 1900. I think it was on 14th December 1899 that Planck made that announcement. And eventually he got a Nobel Prize in 1918. So it took like 18 years. Einstein's work on photoelectric effect in 1905 got him a Nobel Prize in 1921. So it took like 16 years. And here is Raman, who does his work in 1928 and gets it in 1930, just within 2 years. And there was no other example of this kind except the work of von Laue, X-ray diffraction. So Laue had got a Nobel Prize in 2 years. And the reason is what you read in Alfred Nobel's will. Nobel categorically states, and this is present in the statutes of the Nobel Committee, that the award is intended for works during the preceding year for the most recent achievements in field, and for older works only if their significance has not become apparent until recently. So sometimes, the interpretation, the importance is not recognized for a long time, and it takes, means Einstein's work on relativity never got a Nobel Prize at the end of the day. So this was the reason. And if you see, the last date to submit proposals for a Nobel Prize is the 1st of February 1930 in this case. But original literature on Raman effect, there were like 225 papers already. Huge interest on Raman's work, and people recognize the importance of his work. And in fact, one of the persons who Robert Wood also nominated was one of the persons who nominated Raman. Robert Wood, he sent a paper to Nature and he says that Raman's work, brilliant and surprising discovery, it appears to me that this very beautiful discovery which resulted from Raman's long and patient study of the phenomenon of light scattering is one of the most convincing proofs of quantum theory. Certainly, it needed the discrete excitation spectrum for bound-to-bound transitions in quantum mechanics, which only quantum mechanics can explain, not classical physics. So here are some important milestones of Raman's life. He was born on 7th of November 1888. His mother Parvati Ammal, father Chandrasekhar Iyer, he was a school teacher, and he was one of the 8 children. So his father was teaching mathematics. He also used to play the violin extremely well. Raman was a brilliant student. So at 13, he already got a scholarship to join the Presidency College in Madras, now Chennai. And he finished his master's at the age of 19. So that's about the age that most of you are here, I think, first year students. Now, this is one aspect which I really want to focus, and if there is anything which is the most important part of my talk today, it is here. So at his age of 16, he carried out some experiments in his lab. These are like routine experiments that you all do in your schools and colleges. But Raman analyzed his results carefully, thoroughly, to the point that he was able to publish in one of the most reputed journals of the time, which was still Philosophical Magazines. In the same issue, he was only 16, he published another article on a totally different topic, on surface tension. So we celebrate not only for Raman effect, but what else he contributed as a physicist, as an experimentalist, and also as a theorist is amazing. So he used to listen to the violin played by his father, and he wrote research papers on the bowed string, the struck string, maintenance, vibrations of resonance, sounds of splashes, and music from heated metals. Now look at the range, just inspired by the recitations by his father at home playing the violin. He discovered overtones of the stretched membranes, the mridangam and the tabla, and he carried out detailed analysis of all the Fourier analysis of these vibrations, and he arrived at conclusions which he eventually published. The richness of mridangam and tabla is far superior to what you get in the normal stretched membranes of Western drums. And this is one of the classic works which Raman carried out. He published a very beautiful paper on the acoustical knowledge of the ancient Hindus. He's very proud as an Indian. And this is very inspiring. So later, when he was director at the Indian Institute of Science, he invited very distinguished physicists to come to India and take up positions in India. People like Schrödinger and Max Born. In fact, I have got a picture of Max Born wearing this typical Mysore Raja's turban, and his wife in a sari. The photograph taken here in Bangalore. It's available on the internet. You will find it. But instead of encouraging young Indian students to go abroad and learn, he was trying to get eminent scientists to come and work here in Bangalore and in India, and this did not go well with the establishment at the time. So he was removed from the position of director of Institute of Science. And Schrödinger very much wanted to come. He said that he had already taken up a position in Ireland, at Dublin. And Schrödinger wrote that he wished that he had come to India, the land of the Upanishads. So they were all very learned people. And they knew a lot about, even our scriptures, perhaps more than what we may know ourselves. So Raman was removed from the directorship of the Indian Institute of Science. It was known as Tata Institute at the time. I don't have to tell this to you. Here's another thing. there is the St. Paul's Cathedral in London. There is a Whispering Gallery. And I'm going to show you a picture of the Whispering Gallery. Raman did some small experiments in the Whispering Gallery. Again, I had to confess, I have in gallery like a tourist standing in a queue, see this, whisper, see the fun, and then come out. That's all most of us do as tourists. Raman went there as tourists, saw the Whispering Gallery, and he figured out the acoustics of that place. And he wrote a paper on that. He wrote a paper, one of which was published in the Nature and the second in the Proceedings of the Royal Society. Amazing. With what you observe, analyze it fully to the point that you can say something original about that. So that's the kind of brilliance Raman had. And that's the reason I said that if there is anything which I would consider to be the most important part of my talk today, it is this. And then this is the picture of the Whispering Gallery. That along the curved wall, if you whisper anything, it can be heard even as far as 33 meters away. Now, look at this. So here is a paper published in the Royal Society of London on the Whispering Gallery phenomenon by C.V. Raman. This is a picture of that. And here is another paper. After returning to India, he wrote about the Whispering Galleries. There are many in India. And some of you probably already know about this Gol Gumbaz at Bijapur, at Victoria Memorial at Calcutta, Granary in Bankipur near Patna, and so on. So this is Raman's work in 1922. So this was much before the discovery of the Raman effect. So see what a complete scientist. He was amazing. So in 1921, when he was returning to Europe, and on this ship, Narkunda, he was struck by the blueness of the sea. And you have the sea and you have the sky. And Lord Rayleigh, he analyzed this, and you probably read about Rayleigh's scattering in your textbooks. And Rayleigh pointed out that the sea has nothing to do with the properties of water in the sea. And he, of course, very successfully explained the blue of the sky and also some of the other colors that you get at dawn and at dusk. So Rayleigh scattering is a very important phenomenon, and Rayleigh made great contributions. But Raman did some experiments on the ship, and he described that the sea appears even more blue than usual, and figured out the entire scattering phenomenon. And this will remind you of what I mentioned toward the beginning of my talk, that he got the Nobel Prize not just for the Raman effect, but also for his other works on scattering. So this is one of the important ones, and his findings contradicted Rayleigh. Here is another interesting part of Raman's life. He was 19 when he saw Lucas. She was playing Tyagaraja Kirtana on a veena, and he married her. Now, this is one thing I don't want you to attempt to emulate him, because it can land you in the jail. He was 19 and she was only 30. But here is an interesting picture. 10th of December is the date that every year the Nobel Award is given. And Raman was present on 10th of December 1930 to receive the award with his wife. And the Nobel laureates are asked to give a talk on their work within 6 months of receiving the award, because it takes time to prepare a talk. So Raman was prepared with his talk. He knew that he would get it. And as a matter of fact, in the normal course, I mean, this is not the era of the internet and so on. It would take some time for news to reach the candidate. And if Raman was to receive information about his award in the normal course, it would have been impossible to be in Sweden on 10th of December 1930. But he had booked his 2 tickets for him and his wife in advance. That was the level of his confidence. And he was there with a prepared speech, which he delivered the very next day. Nobel lecture he delivered on 11th of December. And here are 2 important quotations from Raman. And there is a message, there are many, he said many things which are very telling. He said that we must teach science in the mother tongue. Otherwise, it will become a highbrow activity. It will not be an activity in which all the people can participate. I think it's a very important thing. He also said that the true wealth of a nation consists not in the stored up gold, but in the intellectual and physical strength of the people. Very inspiring. Please take a note of it. He resented Nehru. In fact, he had put a plate on his gate. Politicians are not allowed to enter my house. And the reason he resented Nehru is because, many of us, Nehru made contributions to science, developed the Atomic Energy Commission, the CSIR labs, and so on. So we all credit him for that. But Raman was critical about it. Raman said that you are concentrating all the resources in these 2 pockets. Everything goes to Atomic Energy Commission, TFR, Bhabha Atomic Research Center, or CSIR labs. And there are these hundreds of universities where there are brilliant students like you. What do they get? And this is not good for science. So Raman was very critical of Nehru's policy. Raman said that CSIR is built as a Taj Mahal built to bury science. Yeah, absolutely.
He says that what they spend and what is the return on investment, it is 0.
Yes.
Now, CAG report said.
Yes. So there is a lot of criticism about this, and so Raman had great commitment to science in the country. He wanted science to reach all corners of the country. He said that Nehru's communist model of the state would be a disaster for India. He said it without mincing words. And Nehru wanted to keep Raman in good books because Raman was very popular. Raman was very popular, and it was not a good idea to go against him. So, what was announced in India? This was 1954. Nehru, as the head of the government, he chose C.V. Raman as one of the recipients for the 1954 award, and Raman smashed that award. Because he knew that it was only to please him, and he said that, okay, what I want you to do for science is to give the money to all the universities and all the colleges and all the students. So that was his demand. Don't try to please me with Bharat Ratna. So this is the Bharat Ratna. This is my last slide. This is the Raman tree at the Raman Research Institute. I hope that all of you, the young students, go and visit. The 1954 award was given to 3 recipients. One was Chakravarti Rajgopalachari, Sarvapalli Radhakrishnan, and C.V. Raman. So these were the first recipients of the very first Bharat Ratna in 1954. Thank you very much. if there is any quick question, I will be happy to make an attempt to answer. Um, while you frame your question, I would like to say that I'm very excited by the fact that there are very brilliant talks lined up for the rest of the day. I'm looking forward to these talks. So, very grateful to all the speakers for coming here. And also very happy about the projects which some of you will be presenting tomorrow afternoon. And if Vijay Kumar, if I can use this opportunity to tell the students over here that I'm here on this campus in the next building, Building B, and I love to work with undergraduate students, and I love to take up projects with them. I don't think I can do anything with you for tomorrow's presentation, but perhaps for next year, if some of you would like to work with me, it will be my privilege. Thank you.
Small note about the CEO Raman works. I think you are quoted. So actually, you are mentioned Ramchandra and Venkateshwaran. They are the students of the CEO Raman. But you forgot one famous person, Surya Bhagavantam is
Yeah.
there.
Yeah.
I think might be. I think the Raman is right lacking for the Jawaharlal Nehru. The Jawaharlal Nehru scientific advisor will be Raman student Surya Bhagavantam.
Yeah.
What I know.
But he preferred his student because of that smooth relationship.
Yes,
Yeah.
But he was originally we come to know that lot of feedback he used to get. Jawaharlal Nehru used to get respect about Raman from abroad.